Yes, guys, there's today's title and learning objective. Underneath your last lesson of work, please rule off and write these down with a new date. Press play when you're ready to keep watching. So we're going to start off today's lesson with a little bit of a do now kind of thing. It's been a while since you've done one of those. I've got two equations here with two unknowns. I've got equation A and equation B. Even though they're not set out like this, x plus y equals something, x minus y equals something. Even though they're not set out like that with the x's and y's together on one side, it's still the same strategy as we've always done, which means we're going to pick one to eliminate, we're going to decide what goes in that box, we're going to subs in one of them, let's say A, we're going to checks in the other one, let's say B. So I want you to pause the video and have a go at the little do now there. You can even give it a title, do now. There you go. Pause the video. Right, so let's do this in black. I'm going to eliminate the y's because I have the same number in front of both of them. So I've got positive y and positive y, which means I'm going to subtract to eliminate them. Gives me 0 y's. 5x minus 2x is 3x. 2 minus positive 5 is minus 3, negative 3. Add 3 to both sides and divide both sides by 3, and I get x equal to 1. Subs in A, so instead of, zoom out a little bit, instead of x, I'm going to be writing 1. Which means I've got 5 plus 2, which is 7. So that's my solution for y. Subs in A, checks in B. Subs in A, checks in B. Subs in B, checks in A. I really hope you're joining in. So I've got y equals 2x plus 5, but I'm changing the y for a 7, and I'm changing the x for a 1. 7 equals 2 plus 5 is 7, so I know that these are correct. So hopefully you got that right. If you missed out any parts or you got something wrong, pause the video and make some notes. And then we're going to look at today's lesson. So if you look at the learning objective, it says, I will use the point where two graphs meet to solve simultaneous equations using graphs exclamation mark in brackets. That's in brackets because, well, it's an exclamation mark because I think actually this is really interesting. Because until now, you've just seen algebra, the solving simultaneous equations, as an algebraic process, which is on the board right now. What we're going to look at today is the fact that actually there's another way you can do it. So here is my grid. Zoom in a little bit. And I'm going to quickly draw both of these graphs. So I'm going to do equation A in this yellow color here. Hopefully you remember all graphs are in the form y equals mx plus c, where m is the gradient. Gradient is, for every one to the right, how much up or down. So for this graph A here, the gradient is 5, which means for every one to the right, it goes up by 5. And C is the y-intercept. Y-intercept, where x is 0. And in everyday language, it is where the graph crosses the y-axis. C, the y-intercept for equation A, is positive 2, which means it crosses the y-axis here. For every one it goes along, it goes 5 up. So that's the next point. Following this same kind of pattern, 1, 2, 3, 4, 5, and 1, that's another point there. Now I'm going to keep going down to -8 and there. And so these are the points that I'm now going to draw or join together to draw my graph. Get my ruler out, draw a nice clear line. So I want you to try and do the same thing now for equation B. I want you to tell me what M is, or I want you to tell me what C is, and then I want you to consider what it would look like on this grid over here. So pause the video and have a go at doing that on your own. and press play when you're ready for me to go through it. All right, so for this green one, for equation B, m is 2, which means for every one to the right, it goes up by 2. C, the y-intercept, is 5, which means it crosses the y-axis at this point here. For every one to the right, it goes up by 2. One to the right, up by 2. And then going down, 2 down, 1 across, 2 down, 1 across, 2 down, 1 across, and you can see it's following that pattern. So I'm going to get my ruler. And I'm going to join all these up nicely. Right. So what I've done here is I've drawn 2 graphs. Where do these graphs meet? Well, they meet at this point here. What is that point? It's at the point 1, 7. Isn't that interesting? 1, 7 is where they meet. Can you spot why that is interesting? If you can't spot it yet, pause the video and give yourself time to look at all the work we've done today, including the do now. Hopefully you've spotted where the 2 graphs, the 2 lines A and B meet, this point here 1, 7, that is also the solutions to when we solved it where x was 1 and y was 7. Look at that! That is why there's an exclamation mark in the yellow. It's because that's mad. Well, it's not mad, it makes a lot of sense. But the point is, simultaneous equations can be solved 2 ways. The first way is by doing the algebra, which is what we've been practicing for the last 2 weeks. But the second way is by drawing the graphs and finding out where they meet. And where they meet, which is technically called their point of intersection, that gives you the solution to the simultaneous equations. And that's what today's lesson is about. It's about drawing graphs and seeing where they meet, finding their point of intersection, in order to solve the simultaneous equations. So there's quite a lot for you to get your head around there. So I want you to pause the video and make any notes that you need to. And if you need to rewind any part of that, then obviously do that and press play when you're ready to keep going. So let's look at an example over here. So this example here, zoom in a little bit. Let's call it EG1. Says, draw the graphs of the lines below on the same grid to find the coordinates of the points of intersection. Now guys, simultaneous equations, this topic, I don't want you to spend loads of time in your book drawing out a perfect grid like this, x, y, 0, and then doing a perfect scale and going through all this, because it's going to be very long. So I'm going to show you a helpful way of answering these questions for this lesson using the internet. So when you're asked to draw the graphs of the lines below, what you're going to do is you're going to go onto the internet. Go on the internet. Ooh, that's my channel. Oh, 4,200 views in the last 28 days. It's not bad. 77 subscribers. Oh well. Sorry. How was that? What? That's pretty funny that was there. Yeah. Anyway, we're going to go. So let's just go through that again. When you're asked to draw the graphs of the lines below, rather than going through and doing it in your book, I'm going to help you do it an easier way on the internet. You're going to go to desmos.com. Desmos.com. You don't need to write the calculator bit, just write desmos.com. And then it'll bring you to this, and you just click graphing calculator. Now the beauty of the graphing calculator is that I've just moved these 2 pages so they're half and half. What we can do is we can draw any line. So let's first of all draw this one. Y equals 2x minus 1. Now you should be thinking to yourself in your head as you do this, well, I know that the y-intercept is -1. I know the gradient is positive, so it's going to look like that. But this thing enables you to type it in, and oh look, there is the graph. How helpful is that? And you can see the y-intercept is at that point there, 0, -1, and the gradient is, for every 1 to the right, it's going up by 2. So that's the first graph. Second graph, this one here. You should be thinking to yourself, what does that look like? Pause the video and have a think about what that looks like. Maybe sketch it out in your book. Well, you should be thinking the y-intercept is -2. It's got a positive gradient of 3, so for every 1 to the right, it goes up by 3. So it's going to look something like that. Actually steeper than the last one because the gradient is 3, not 2. Now we're going to look at it on here. Y equals 3x minus 2. Look, there is the graph, and there you can see I've got the shape correct. The y-intercept is at 0, -2, like I said over here. And it got a positive gradient. Now, let's go back to our question. Draw the graphs of the lines below on the same grid to find the points of intersection, which is the same as to solve these two equations, these two here, A and B, simultaneously. So we're going to go over here to our graph, and we can see they meet at this point here. That is their point of intersection, where x is 1 and where y is 1. And so therefore, that is our solution. And we're going to write them as coordinates 1, 1. This is how you use graphs to solve equations simultaneously. You draw the graph and you find the points of intersection. So, pause the video and make any notes that you need to, and we'll do another example. Example 2. Solve these equations by drawing their graphs. So what I want you to do in a moment is you're going to sketch both graphs so that you can practice looking at what the shape of the graph looks like. Then you're going to open Desmos. You're going to draw the graphs like I've just shown you. Then finally, you're going to look for their points of intersection or point of intersection in order to get a solution. And I want you to write the solution as 2 coordinates with brackets. So pause the video and have a go at doing all of that, and press play when you're ready to keep going. Right, so let's look at equation A first of all. Y equals 2 minus x. Remember, it's the number in front of the x that is the gradient. So the gradient is -1 and the y-intercept is 2. M equals -1, C equals +2. Which means it crosses the y-axis at +2 and it's going down because there's a negative gradient. That's what I think that graph looks like. Let me check. Get rid of my graphs from before. I'll write y equals 2 minus x. There it is. You can see it's crossing the y-axis at 0, 2, and it's going down from left to right. So I know that this over here, this is correct. Whoa, what's happening? Zoom out a little bit so I've got a bit more space to do equation B. So equation B, there is no number on its own, which means that C equals 0. And gradient is the number in front of x, so for the second graph, M is -2, C is 0, which means it's crossing the y-axis where y is 0, and the gradient is negative but even steeper than the last one. This is all just revision of the work we did in the first term. Let's have a look over here. So I'm doing y equals negative 2x, and look, you can see it's going through that point 0, 0, and it's got a negative steeper gradient. I've plotted them on Desmos. So this bit, that's correct. I've done this bit. The point of intersection, that's where they meet. Let's have a look. They meet. Let's make this nice and big. You can move around like that. Very nice. Desmos is very nice. You can scroll in and scroll out. But the point is, the point of intersection is that point where x is negative 2 and y is 4. If you were to write it like this, you'd say x is negative 2, y equals 4. What that means is this and this are the precise values that if you substituted them into here and here, they would work. The equations would make sense. Let's just double check. Let's check in equation A first of all. Y equals 2 minus x. So instead of y, I'm writing 4 because of this. Instead of x, I'm writing negative 2 because of that. 4 equals 4. Bingo. Looks right. And then I could check it in B as well, just to double confirm. So pause the video and make any notes that you need to, and press play when you're ready to keep watching. All right, one more question. Example 3. And again, I want you to solve these simultaneously, but by drawing the graphs using Desmos. Pause the video and have a go at that, please. Let's just make sure we know what we're doing. Equation A, or graph A. I should have asked you to draw a sketch quickly before. This one's a bit more tricky because it's not in the form y equals mx plus c. So we've got to make it in the form where y is the subject. So take away 4 from both sides. Divide both sides by 2. So therefore m is a half, c is negative 2, which means it's going through there, and it's got a gentle positive gradient like that. Equation B, over here, it's much easier. Y equals 2x plus 1. Y-intercept is 1. C equals 1. M equals 2, which means it's going up more steeply than the last one. Like that. Let's check if they're right, and then we'll see where they cross. So that's equation A. You can see I got it right. It's going through that point 0, negative 2. Equation B, there it is. You can see over here, I got it right. It's going through the point 0, 1, and it's going up. And where they meet is at negative 2, negative 3. So my solution to this question over here or x is negative 2 and y is negative 3. So pause the video and make any notes that you need to. Now, when you're doing the Hegarty maths quizzes, I want you to use Desmos to draw the graphs. If you want to really push yourself and practice drawing loads of graphs, and I don't mind if you do it in your book, but to save time, I recommend you do Desmos, because today is all about understanding how to use graphs to solve simultaneous equations. It's not necessarily about drawing the graphs themselves, because we practiced that last term. So if you need to rewind any part of that, pause the video, rewind it, rewind the bits that you were not sure about, and then have a go at the Hegarty maths tasks that it's saying to have a go at on Show My Homework. Thanks for watching. Don't forget to boost that subscriber list, yeah? Bye.